Dear students, we will see D Alemberts principle today. So, Newton's second law states that a resultant force F bar causes an acceleration A bar which is in line with F bar, that is direction, and it is given by F bar is equals to m into A bar. Okay, so this is Newton's second law, we already know it. Okay, the effective force on the particle is defined as the resultant force on the particle. Okay, so effective force and resultant force nearly same. So since F bar and ma bar are numerically equivalent, either of them may be the effective force on the particle. Okay, next, D Alemberts principle. Okay, the reversed effective force at each point of the system of bodies and the impressed forces on the system are in equilibrium. So what is said? The reversed effective forces at each of the point of the system of bodies and the impressed forces on the system are in equilibrium. Okay, so F bar plus into bracket minus of ma bar bracket close is equals to 0. Okay, where minus ma bar is reversed effective force. Okay, so importance or significance of D Alemberts principle. D Alemberts principle reduces the solution of dynamic problem to a problem in statics. Okay, now this principle applied to rectangular components. Consider a system of forces acting on a particle. Let summation of fx and summation of fy be the components of resultant along x and y axis. Okay, let ax and ay be the components of acceleration along x and y axis. Now, so this is the diagram, x and y coordinates axis. So this is the curve, this is the point under consideration. Okay, now the point is P having mass m. Okay, force acting towards right hand side or positive x direction is summation of fx. Okay, while minus max is acting exactly opposite to it. Okay, summation of fy, summation of y, component of the resultant force along y direction. Okay, and ay is a component of acceleration along y direction, minus mau or exactly opposite direction, may. Okay, so what is said? Summation of fx is equals to max, where m is mass, and summation of fy is equals to may. This is known from the Newton's second law. Okay, so summation of fx plus into bracket of minus max is equals to 0. Okay, and summation of fy plus into bracket minus may is equals to 0. Okay, so this is the form which D Alemberts principle takes in rectangular components. Okay, now these equations, these equations are called equations of dynamic equilibrium, where max and may are the inertia forces acting on the particle in a direction opposite to the direction of acceleration ax and ay. Okay, so minus ax and minus ay are called inertia forces acting. Okay, so next, D Alemberts principle to tangential and normal components. Okay, so let us see, this is the curve, this is the point under consideration. Okay, a tangent is like this, and summation of f of t is the summation of forces along the tangential direction. In opposite direction it is m into a of t. Okay, So in this normal direction, sum of f of n is the summation of forces, and m a into n m a n is the summation of forces, exactly opposite to it. Okay, summation of ft is equals to m into at. Okay, force is equals to mass into acceleration. This is we know it. Okay, t means tangential direction. Okay, and this is equals to m into dv by dt. M as it is, acceleration in tangential direction is equals to dv by dt. Okay, summation of f of n. So a summation of forces in n direction, summation of fn is equals to m into an, mass into acceleration into normal direction, and this an is equals to v square by rho. Okay, now summation of f of t and f of n are the components of summation of uh, forces along tangent and normal, and at and an are the tangential and normal components of acceleration. Okay, the above equation can be written as summation of f of t minus summation of f of t plus into bracket minus m a t is equals to 0, again as the earlier form. Summation of f of t plus minus m into at is equals to 0, and summation of fn. Okay, so force in this normal direction, summation of fn plus into bracket minus m into an is equals to 0. Next, these are called equations of dynamic equilibrium. These two are called dynamic equilibrium, and minus m into at and minus m into an are called inertia forces added to the system of forces. Okay, system of forces acting on the particle in the direction opposite to the direction of acceleration of at and an. Okay, thank you.